Hey, dear students, I'm going to walk you through the data abstraction quiz, which should be our big idea 3 on programming and algorithms, and topic 2, data abstraction. We're talking about lists in general, but there's other data abstractions. So I'll just try to walk through these questions pretty quickly. Question number 1. Which of the following is a benefit of using a list as a data abstraction in a program? So lists in general allow us to uh, simplify program. And for example, if you have want to manage, let's say, student lists for different courses, well, first of all, you don't know how many students you'll have in a class and how many classes you're going to have. So you just don't know how many variables you might need for some programs. And then also, it would be very impractical. To label variables like student number 1, student number 2, student number 3, student number 4, and so on. But even more importantly, we want to iterate through the lists. We use lists, which we use loops, which we haven't really studied in specifically yet. But very often we use loops to traverse and iterate through the lists to process them, to search for something or do some mathematical function using numbers in the list or sort or whatever. So anyway, which of the following is a benefit? Lists often allow their size to be easily updated to hold as many data values as needed. Well, that's definitely a benefit. Lists convert all elements to strings. That's not true. Lists prevent duplicate data values. Nope, that's not true. You could have lists of all of the same numbers. List of 3 million sevens. Lists are used to store all input data so that there is no running record of all. So there's a running record of all user input. No, that ain't true. That would be unmanageable. Most of the data that is inputted into the devices is lost because we could not capture and maintain all of it. Obviously, like right off the top, I knew it was A, but wanted to explain why the other ones weren't correct. Let's see. Number 2. A programmer has a need to round many numeric values to the nearest integer. Which of the following best explains the benefit of using a list as a data abstraction in this situation? Well, I know, and it's been a while since I looked at these questions, so I don't remember the choices yet, but I know right away that the idea here is you can send lists as a chunk to a function, and you can iterate through using loops to do the same operation on many different variables without having to, have 10,000 lines of code to do the same thing to 10,000 different variables. You just have a loop that repeats the same operation 10,000 times on different elements of the list. So we just need to find the option that describes that. Keeping the numeric values in the list makes it easier to round the number to the nearest integer. Nope, not really. You can round the number no matter if it's in a list or a variable. Lists are just a collection of variables, so that's not true. Keeping the numeric values in a list makes it easier to apply the same computation to every data element. Yes, but let's see if there's other ones that are more specific. Let's see. Keeping the numeric values in the list makes it easier to prevent the program from unintentionally. Nope, that's not true. You can, that doesn't work. Keeping the numeric values in the list makes it easier to prevent the program from attempting to access an index beyond the length of the list. No, it does not. You just have to watch out for that regardless. So it's this one here. It's just it makes it easier to apply the same computation to every data element. They just don't explain that it's because you would either, just send the entire list to the function instead of having to, send individual variables. Or if you're traversing, using a loop to traverse a list, you could use the same command and, for each element of the list. Let's see. Number 3, assume that both lists and strings are indexed starting with index 1. The list word list has the following contents: ABC, then DEF, GHI, and JKL. So this is 4 elements in a list. Each of them is a string with 3 letters. So that's word list. Okay, that's this word list. Now let my word is of one variable. be the element at index 3. So it says that indexing starts at index 1, which is, I don't like that they do that here, but most languages start indexing at 0. In AP Classroom, in an AP exam, they start indexing with 1, which is annoying. But anyway, so this would be index 1, this would be index 2, this would be index 3, this would be index 4. As in, I have multiple elements in the list, and they're all number first, second, third, fourth. Um, or number 1, number 2, number 3, number 4. So index 3 would be this one. If this is index 1, index 2, index 3. So index 3 is just the address of that element. The actual value of it is GHI. So my word is GHI. Let my character be the character at index 2 of my word. So within GHR, we have 3 letters, first, second, and third. What is the value of my character? So here again, the strings are indexed starting with 1, which is not common practice. So again, I'm not a fan of it, but that's what they have. So the answer here is H. C. That's the second letter of the third list in the word. So my word is the third list of word list, third element of the word list, and then my character is the second letter of my word, which would be that H right there. Okay, so let's see. We have some pseudocode here in blocks. We have your list. Your list is assigned these 4 numbers, and then my list is assigned these other 4 numbers. So we have the even decades and the odd decades. And then it says my list, I'm sorry, it says your list is assigned the value of my list, or if you will, my list is assigned to your list, which means that your list now becomes whatever my list is. So now both of them are 10, 30, 50, 70. So what are the contents of your list? Whatever my list was originally. So that arrow points the direction of which the data is going. So it's going from my list to your list. So this one stays the same. My list stays the same. Your list is overwritten with 10, 30, 50, and 70. It's overwritten, overwriting the original. It's not like adding them or anything. It's just literally there's an append function that adds values. But in here, we're just basically saying whatever this was before doesn't matter. Here's a new thing that's going into it. So now your list is equal to my list, which is 10, 30, 50, 70. Which in this case is A. So they're not, you know, um, it's been changed, overwritten, so they're not, added together in any particular order. It's just overwritten. All right, let's keep going. Consider the following code segment. First list is guitar, drums, bass. Second list is flute and violin. Third list is blank. So now third list becomes first list. So third, and again, this might help if you have it on paper, like to jot down some notes on paper sometimes. But let's see if we can follow it. So third list was blank, but now takes on the value of the first list. So now first and third lists are guitar, drums, and bass. So that goes down into the third list. First list now becomes second list, or second list values are assigned to first list. So it overwrites the first list. So now third list is still guitar, drums, and bass, but first list now is overwritten with flute and violin. So both first and second lists are for flute and violin at this point. And then finally, we have this last line. Second list is equal to now third list. So third list was guitar, drums, and bass. So now second list is also guitar, drums, and bass. However, the first list is flute and violin. So what are the contents of second list? Guitar, drums, and bass. And 1, 2, 3, 4, 5, 6. Question number 6. The word list contains a list of 10 string values. Which of the following is a valid index for the list? Well, they can't be negative. There's no negative index values. They start with 1, and they have to be integers. They can't be text. They're just numerical addresses, basically location, first, second, third, fourth, but just numerical like 1, 2, 3, 4. And then they can't be decimal. There's no spots in between them. There's just like first, second, and third. There's no first and a half, second and a half. So the 4 would be the only valid index in this list. Alrighty, thank you.